The Search for Signals from Space. By Carl Sagan. After billions of years of biological evolution on their planet and ours, an alien civilization cannot be in technological lockstep with us. There have been humans for more than 20,000 centuries, but we've had radio only for about 1 century. If they're behind us, they're likely to be too far behind to have radio. And if they're ahead of us, they're likely to be far ahead. What is for us technologically difficult or impossible, what might seem to us like magic, might for them be trivially easy. They might use other, very advanced means to communicate with their peers, but they would know about radio as an approach to newly emerging civilizations. Even with no more than our level of technology at the transmitting and receiving ends, we could communicate across much of the galaxy. They should be able to do much better. If they exist. But our fear of the dark rebels. We conjure up objections. It's too expensive. But, in its fullest modem technological expression, it costs less than 1 attack helicopter a year. We'll never understand what they're saying. But, because the message is transmitted by radio, we and they must have radio physics in common. The laws of nature are the same everywhere. So science itself provides a language of communication even between very different kinds of beings, provided they both have science. It would be demoralizing to learn that our science is medieval. But, by the standards of the next few centuries, at least some of our present science will be considered medieval, extraterrestrials or no extraterrestrials. So will some of our present politics, ethics, economics, and religion. To go beyond present science is one of the chief goals of science. A serious student is not commonly plunged into fits of despair on turning the pages of a textbook and discovering that some further topic is known to the author but not yet to the student. Usually the student struggles a little, acquires the new knowledge and, following an ancient human tradition, continues to turn the pages. All through history, advanced civilizations ruin slightly more backward civilizations. Certainly. But malevolent aliens, should they exist, will not discover our existence from the fact that we listen. The search programs only receive, they do not send. The debate is, for the moment, moot. We are now, on an unprecedented scale, listening for radio signals from possible other civilizations in the depths of space. Alive today is the first generation of scientists to interrogate the darkness. Conceivably, it might also be the last generation before contact is made, and this the last moment before we discover that someone in the darkness is calling out to us. This quest is called the Search for Extraterrestrial Intelligence, SETI, and I want to describe how far we've come. The first SETI program was carried out by Frank Drake at the National Radio Astronomy Observatory in Greenbank, West Virginia, in 1960. He listened to 2 nearby sun-like stars for 2 weeks at one particular frequency. Nearby is a relative term, the nearest was L2 light-years 70 trillion miles away. Almost at the moment Drake pointed the radio telescope and turned the system on, he picked up a very strong signal. Was it a message from alien beings? Then it went away. If the signal disappears, you can't scrutinize it. You can't tell if, because of the Earth's rotation, it moves with the sky. If it's not repeatable, you've learned almost nothing from it. It might be terrestrial radio interference or a failure of your amplifier or detector, or an alien signal. Unrepeatable data are not worth much. Weeks later, the signal was detected again. It turned out to be a military aircraft broadcasting on an unauthorized frequency. Drake reported negative results. But in science, a negative result is not at all the same thing as a failure. His great achievement was to show that modern technology is fully able to listen for signals from hypothetical civilizations on planets of other stars. Since then, there have been other attempts, often on borrowed time, almost never for longer than a few months. There have been some more false alarms at Ohio State, at Arecibo in Puerto Rico, in France, Russia, and elsewhere, but nothing that could pass scientific muster. The Planetary Society is a 100,000 member nonprofit organization that the planetary scientist Bruce Murray and I founded in 1980. It is devoted to exploration of the solar system and the search for extraterrestrial life. Paul Horowitz, a Harvard University physicist, had made a number of important SETI innovations and was eager to try them out. With support from our members, including the filmmaker Steven Spielberg, we began Project META. META is an acronym for Megachannel Extraterrestrial Assay. The single frequency of Drake's first system has now grown to 8.4 million. But each channel, each station we tune to has an exceptionally narrow frequency range. There are no known processes out among the stars and galaxies that can generate such sharp radio lines. If we pick up anything falling into so narrow a channel, it must, we think, be a token of intelligence and technology. What's more, the Earth turns, which means that any distant radio source will have a large apparent motion, like the rising and setting of the stars. Just as the steady tone of a car's horn dips as it drives by, so any authentic extraterrestrial radio source will exhibit a steady drift in frequency due to the Earth's rotation. But any source of interference at the Earth's surface will be rotating as fast as the META receiver. META's listening frequencies are continuously changed to compensate for the Earth's rotation, so that a narrowband signal from the sky will always appear in a single channel. Any radio interference down here on Earth will give itself away by racing through adjacent channels. The META radio telescope in Harvard, Massachusetts, is 26 meters, 84 feet, in diameter. Each day, as the Earth rotates the telescope beneath the sky, a swath of stars narrower than the full moon is listened to. Next day, it's an adjacent swath. Over a year, all of the northern sky and part of the southern is observed. An identical system, also sponsored by the Planetary Society, is in operation just outside Buenos Aires, Argentina, to examine all of the southern sky. In the latest issue of the Astrophysical Journal, Paul Horowitz and I have detailed the results from 5 years of full-time searching with Project META and 2 years of follow-up. We can't report that we found a signal from alien beings. But we did find something puzzling, something that, for me, every now and then, raises goosebumps. Of course, there's a background level of radio noise: TV stations, aircraft, portable telephones, spacecraft. Also, as with all radio receivers, the longer you wait, the more likely it is there will be some random fluctuation in the electronics so strong that it generates a spurious signal. So we ignore anything that isn't much louder than the background. Any strong narrowband signal that remains in a single channel we take very seriously. As it logs in the data, META automatically tells the human operators to pay attention to certain signals. Over 5 years, we've made some 60 trillion observations at various frequencies while examining the entire accessible sky. A few dozen signals survive the culling. These are subjected to further scrutiny, and most of them are rejected. What's left the strongest candidate signals after 3 surveys of the sky are 11 events. They satisfy all but one of our criteria for a genuine alien signal. But the one failed criterion is supremely important: verifiability. We've never been able to find any of them again. We look back at that part of the sky 3 minutes later, and there's nothing. We look again the following day, nothing. Examine it a year later, or 6 years later, and still there's nothing. Although none of these signals repeats, there's an additional fact about them that, every time I think about it, sends a chill down my spine. 8 of the 11 best candidate signals lie in or near the plane of the Milky Way galaxy. The Milky Way is a flat, wheel-like collection of gas and dust and stars. Its flatness is why we see it as a band of diffuse light across the night sky. That's where almost all the stars in our galaxy are. If our candidate signals really were radio interference from Earth or some undetected glitch in the detection electronics, we shouldn't see them clustered toward the Milky Way. But maybe we had an especially unlucky run of statistics. Without repeatable signals, there's no way we can CONC1UDE that we've found extraterrestrial intelligence. Let's permit ourselves, though, a moment of extravagant speculation. Let's imagine that all of our surviving events are in fact due to radio beacons of other civilizations. Then we can estimate from how little time we've spent watching each piece of sky how many such transmitters there are in the Milky Way. The answer is something approaching 1,000,000. The nearest of them would be a few hundred light years away, too far for them to have picked up our own TV or radar signals yet. They would not know for another few centuries that a technical civilization has emerged on Earth. The galaxy would be pulsing with life and intelligence but oblivious to what has been happening down here lately. A few centuries from now, after they do hear from us, things might get very interesting. If, on the other hand, none of our candidate signals is an authentic alien radio beacon, then we're forced to conclude that very few civilizations are broadcasting, at least at our frequencies and strongly enough for us to hear. Imagine a civilization something like our own but which dedicated all its available power to broadcasting at one of the meta frequencies and directly at our position in space. Then, if the meta results are negative, there can be no such civilizations anywhere among the 400 billion stars in the Milky Way. But how would they know to transmit in our direction? So, even if the meta results are negative, the possibility remains of a broad range of civilizations more advanced than we are and broadcasting omnidirectionally. We would not have heard from them yet. On October 12, 1992, NASA turned on its new SETI program. At a radio telescope in the Mojave Desert, a search was initiated that will systematically cover the entire sky making, like META, no guesses about which stars are more likely but greatly expanding the frequency coverage. At the Arecibo Observatory, an even more sensitive study also began, concentrating on promising nearby star systems. When this is fully operational, the NASA's searches will be able to detect much fainter signals than META and to look for kinds of signals that META could not. The META experience reveals a thicket of background static and radio interference. Quick reobservation and confirmation of the signal, especially at other, independent radio telescopes, is the key to being sure. Meanwhile, Paul Horowitz and I have given the NASA scientists the coordinates of our fleeting and enigmatic events. The NASA program is developing new technology, stimulating ideas, and exciting school children. In the eyes of many, it is well worth the $10 million a year that's being spent on it. The U.S. defense budget is some 30,000 times larger. Jointly supported by the Planetary Society and NASA, Horowitz has come up with a new program different from META, different from what NASA is doing, called BETA, which stands for Billion Channel Extraterrestrial Assay. It combines narrowband sensitivity, wide frequency coverage, and a clever way to verify signals as they're detected. If the Planetary Society can find the additional support, this system should be on the air within the next few years. Would I like to believe that, with META, we've detected transmissions from other civilizations out there in the dark, sprinkled through the vast Milky Way galaxy? You bet. To me, such a discovery would be thrilling. It would change everything. We would be hearing from other beings independently evolved over billions of years, viewing the universe perhaps very differently than we, probably much smarter, almost certainly not human. What do they know? The knowledge that such other beings exist and that, as the evolutionary process requires, they must be very different from us would have a striking implication. Whatever differences divide us down here on Earth are trivial compared to the differences between any of us and any of them. Maybe it's a long shot, but the discovery of extraterrestrial intelligence might play a role in unifying our squabbling and divided planet. It would be a rite of passage for our species, a transforming event in the ancient quest to discover our place in the universe. In our fascination with SETI, we might be tempted, even without good evidence, to succumb to belief. But this would be self-indulgent and foolish. We must surrender our skepticism only in the face of rock-solid evidence. Science demands a tolerance for ambiguity. Where we are ignorant, we withhold belief. Whatever annoyance the uncertainty engenders serves a higher purpose, it drives us to accumulate better data. This attitude is the difference between science and so much else. Science offers little in the way of cheap thrills. The standards of evidence are strict. But, when followed, they allow you to see far, illuminating even a great darkness.